We get coffee, the drink, by extracting coffee, the stuff, from coffee, the beans, using water. Smaller particles extract faster than larger particles and impart different taste to our brew. It makes sense to try and grind particles to the same size to extract the same amount and give consistency. But it's not that easy to get a consistent size. Coffee is brittle like rock, and it fractures like rock. When engineers want to turn rocks into uniformly sized aggregate, they use cone crushers or jaw crushers to progressively fracture the rocks. To turn the beans on the left into the grinds on the right, we use various kinds of burrs to crush and cut the coffee beans. Just like our engineers with their rock crushers, we always end up with various sizes of ground coffee. The modal size is the most frequent particle size in the spread. The grinds below 50 micrometers are called fines. The grinds above 1,000 micrometers are called boulders. If we calculate the volume that each particle size contributes to the overall volume, we get a particle size distribution curve. Remember, the small fines have greater surface area and so extract faster, and at the other end the boulders have much less surface area and so extract much slower. And the modal particles are the closest to what we intended to grind. We generally try to extract 18 to 22% of the coffee into water. However, when our extract mojo tells us that we've got 20% extraction, we've actually extracted differing amounts from the various particle sizes, something like this. The water extracts compounds from the fines much faster than the larger grinds. To compensate for this, we might under-extract the modal particles. Doing so, we've just set our grinders for an average extraction. This means that the fines have a disproportionate impact on our judgment of when to stop the extraction. Some people have focused on removing fines, believing that they can extract much more of the intended modal grinds without the overall brew becoming too bitter. Graphically, it would look like this. Removing excess fines means that we can increase the extraction of the rest of the coffee without the extreme bitterness. In order to reduce fines, we could get new burrs. We could also get bigger discs. Bigger discs means fewer fines, a narrower particle size distribution curve, and less heat. The other option is to get a better grinder. Some people reckon that the EK43, developed in the 1980s, is the best grinder going for reducing fines. It can grind very finely with comparatively few fines. Some cafes have used it for grinding espresso, such as Third Floor Espresso in Dublin and Proud Mary in Melbourne. If you're interested in this, check out Matt Purger's 2013 World Barista Championship spiel. If surface area is the greatest factor in the rate of extraction, why are we looking at volume percentage? Let's overlay a rate of extraction graph over the particle size distribution graph. We see that extraction is off the charts for grinds below 70 microns. We actually get most of our extraction from fines. The reason that the EK43 is good is because the spread of sizes is less, rather than because it creates fewer fines. The EK43 actually produces more fines than the Ampham Kaimano grinder. The reason it's better is because a narrower spread means that there's less of a difference in size between the smallest and largest grinds. For filter coffee, rather than eliminating the fines, maybe we should accept them as inevitable. We should be eliminating the multi-cell grinds instead, although filtering the brew from the fines will be tricky. So maybe the best thing is to continue with our multi-modal grinding. After all, espresso needs permeable and non-permeable grind sizes, and multi-modal filter brews can also taste good. Here's a question for you. Which one of these particle size distribution curves would taste better? Who knows? The different particle sizes extracting at different rates may add complexity, leaving the uniform grinds from our excellent grinder tasting flat. Or perhaps the excessive grinds would tend to be bitter, causing her to under-extract the modal grinds, and the near-perfect particle size distribution allows the precision barista to pull exactly the shot he wants. It always comes back to what tastes best in the cup.